In this video, we're going to look at the probabilities of sequences of events. So the probabilities of events happening in sequence one after each other. For a sequence of events, we're going to use this reasoning. The probability that event A happens and then event B happens is equal to the probability that A happens multiplied by the probability that B happens after event A has happened. So that event, probability of B happening after event A has already happened, might not be the same as event B before event A has already happened. Let's look at an example. We have a bucket of 5 balls. There are 4 red balls and 1 blue ball in this bucket. What is the probability that if we randomly put our hand in this bucket, that we first choose a blue ball and then without putting that back in, we then choose a red ball? So from that reasoning we just looked at, that is the probability that we pull out a blue ball multiplied by the probability that we pull out a red ball after the blue one has been removed. There are 5 balls and 1 of them is blue, so the probability of pulling out a blue ball is 1/5. What is the probability of pulling out a red ball after the blue one has been removed? Well, after the blue one has been removed, all the balls are red, and so that is guaranteed to happen, and that is a probability of 1. So the probability of pulling out a blue ball and then a red ball is 1/5. What about the other way around? What is the probability of pulling out a red ball and then pulling out a blue ball? So again, we're going to work through the same logic. Probability of that sequence of events is going to be the probability of pulling out a red ball multiplied by the probability of pulling out a blue ball after a red has been removed. So there are 4 red balls out of 5 possible balls, so probability of pulling out a red ball is 4/5. What is the probability of pulling out a blue ball after the red ball has been removed? Well, we remove a red ball. Now there are only 4 balls left and 3 of them are red. So that's 1/4. 4/5 multiplied by 1/4 is 1/5. So in this case, it didn't matter the order at which we pull out the balls. Now, that's not always the case. Order does matter when it comes to probability. What is the probability of either pulling out red and then a blue, or a blue and then a red? So we're asking, what is the probability that if we pull out 2 balls, it'll be blue and red? There are 2 ways of working this out. So I think maybe one of the simplest ways, I'll do this on the whiteboard, is to list out all possible combinations. So what are the combinations that we can pull these balls out? Well, we can first pull out a blue ball, and then what's left is pulling out a red ball. But there are a choice of 4 red balls. We could have pulled out any of those 4 red balls. So this can happen 4 different ways. What if we chose a red ball first? So if we chose a red ball first, then we could choose the blue ball next, but we could have chosen a red ball next. And there are 3 other red balls to choose from, so this can happen in 3 different ways. And again, this whole sequence can happen in 4 different ways because there are 4 red balls we can choose from at the start. So these are all the combinations of pulling out 2 balls from this bucket that can occur. We are concerned with either pulling out a red and then a blue, or a blue and then a red. So how many of those outcomes are there that we're concerned about? 1, 2, 3, 4, 5, 6, 7, 8. So the size of the event we are concerned about is 8. What is the size of the sample space? Well, there are 20 outcomes altogether. So what is the probability of event E occurring? That is 8 over 20, which simplifies to 2/5. Now that is not the simplest way of doing this. We can work this out by considering sequences of events. And an easy way of doing that is something called a probability tree. So the first event to happen, two things can happen. Either we pull out a red ball or we can pull out a blue ball. After that has occurred, if we pulled out a red ball, two more things occur. So we can branch off. Two more things occur. We can either have pulled out a second red ball or pulled out a blue ball. Now if we first pulled out a blue ball, two more things can occur. We can either have pulled out a red ball or we could have pulled out a blue ball. So these are all the potential things that could have occurred. And now what we'd like to do is assign probabilities to these branches. How likely are you to travel down one of these branches? So when you first choose a ball, there are 5 balls in the bucket, 4 of them are red, so there's a 4/5 chance of you choosing that red ball. There's 1 of them are blue, so there is a 1/5 chance of you choosing that blue ball. Now once you've chosen that red ball, you've taken one of the red balls out, and so 3 of the 4 balls that are left are red, so there's a 3/4 chance of choosing a red ball again, and 1 of the 4 balls that are left are blue, so there is a 1/4 chance of choosing the blue ball after the red. If you chose the blue ball, then there are 4 out of 4 of the balls are red, so there's a guaranteed chance that you will choose the red ball next, and 0 of the 4 balls are blue, so there is a 0 chance of you choosing the blue ball. It's impossible to choose a second blue ball when there's only 1 blue ball at the start. Now, if we think about what that equation we've been using throughout this was, the chance of a red and then a red ball being chosen is the probability of choosing the red ball multiplied by the probability of choosing a second red ball once the red ball's been occurred. So now all we are doing is multiplying along those branches. 4/5 multiplied by 3/4 is 3/5, and we can do the same for each of the possible branches. Choosing a red ball and then a blue ball is 4/5 multiplied by 1/4, a fifth. Choosing a blue ball and then a red ball is 1/5 multiplied by 1. And choosing a blue ball and then a blue ball is 1/5 multiplied by 0, which is 0. What's really neat about this way of doing it, not just that it's visual and we've considered every possibility without all getting confused in our calculations, but all the end branches there, red, 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 blue, blue, red, blue, blue, they are each mutually exclusive from one another. They can't happen at the same time. And because of that, because they can't happen at the same time, we know we can add up their probabilities. If we want one or the other, the union of those events, we can just add up their probabilities. So what is the probability of either having a red then a blue ball, or having a blue and then a red ball? That is going to be a fifth, this fifth, plus this fifth, which is 2/5, which corresponds to how we worked out the other way. But probability trees are a lot nicer and neater way of doing that, especially when you have events which are not equally likely, and especially when you get much more complicated situations. Let's look at one other example. So a school wants to know the proportion of pupils who drink alcohol underage. Now they don't want to identify the children because this is going to cause problems for the children, and the children might lie. So they devised the following system just so they know the proportion of pupils and nothing else. Pupils are asked to roll a fair die. If they roll a 3 or a 4, they must answer truthfully. If they don't answer a 3 or a 4, they must lie. As pupils do not record the throw of their die, the school doesn't know if they are lying or not, but they would know the proportion of people who are meant to be lying. When they collect all the answers in, from the 1,200 pupils they've got, 450 of them said that they drank alcohol underage. How can the school find the true proportion of pupils who drink underage? And probability trees are going to help us with this, along with a little bit of algebra. Okay, so consider you are a pupil. The first thing you do is you need to roll a die. If you roll a 3 or a 4, you must answer truthfully. Otherwise, you must lie. What is the probability of you having to answer truthfully? That is the probability of rolling a 3 or a 4. So that is 2/6. What is the probability of you having to lie? That is all the other possibilities. So that is 4/6. Once you tell the truth, you can either say that you drink alcohol or say that you don't drink alcohol. The same when you lie. Okay? You either say that you drink alcohol or that you don't drink alcohol. If you're telling the truth, what is the probability that you say you drink alcohol? Well, that's going to be the true proportion of the people who drink alcohol. So let's call that P. And if you don't drink alcohol, say you don't drink alcohol, that's going to be 1 minus P. But if you're lying, then you drink alcohol with probability P. So you say you drink alcohol with probability 1 minus P. And you say you don't drink alcohol with probability P, because these are all people who actually do drink alcohol. They've just been told to lie. Now, just like we did with the probability tree in the buckets, we can multiply along these branches to get the probability of each of these events occurring. So the probability of saying you drink alcohol and telling the truth, that's going to be a third times P, so 2/6 times P, 2/6 is a third. And if you're telling the truth and you're saying you don't drink alcohol, that's going to be a third times 1 minus P. Similarly, if you're lying and you say you drink alcohol, that's going to be 2/3 times 1 minus P. And if you're lying and you say you don't drink alcohol, that will be 2/3 times P. Now the school says that 450 of the 1,200 pupils said they drink alcohol. That simplifies to 3/8. And what does that correspond to? That corresponds to all the events where people said they drank alcohol. So that is the event where they tell the truth and they drank alcohol, plus the event where they lied and they say they drank alcohol. And now we have an equation which we can solve using a bit of algebra. Okay, to solve this, we're going to use some of our algebra skills. So we want to find which value of P satisfies this equation. So let's multiply everything out. Now let's minus 2/3 from both sides and collect the p's. So how many p's do we have? We have minus a third p, and we've taken 2/3 away from both sides. Let's multiply it through by minus 3. And we'll write this as one fraction. And so P is 7/8. Remember, what was P? P was the proportion of students who drink alcohol underage, and so the true proportion is 7/8.